The lock chamber walls are 6 feet thick, limestone blocks, hand-cut. Each block weighs between 2 and 4 tons. The Rideau Canal system includes 47 locks spanning 202 kilometers through eastern Ontario. Construction began in 1826. The walls were designed to absorb cannonball impacts during a war with the United States that never came. Colonel John By, British Royal Engineers, supervised construction. His instructions were specific. Build fortifications capable of withstanding sustained artillery bombardment. If the limestone came from local quarries. Workers cut each block by hand, fitted them with quarter-inch tolerance, stacked them without mortar in critical sections. The walls weren't designed for water pressure alone. They were designed for siege warfare. The budget was £169,000 sterling. Final cost, £822,804, nearly 5 times the estimate. By was recalled to London in 1832 to explain the overrun. He provided detailed engineering justification. The walls needed to stop 24-pound cannonballs fired at close range. A 6-foot thickness was the calculated minimum for that scenario. The parliamentary inquiry accepted his explanation but ended his career. He never received another major commission. The war never happened. Relations between Britain and the United States normalized through the 1830s and 1840s. The Oregon Treaty of 1846 reduced tensions. The canal's military purpose became obsolete before commercial traffic fully developed. The 6-foot walls built to stop artillery instead carried timber barges and grain shipments. But the walls endured. Eastern Ontario winters subject limestone to freeze-thaw cycles. Water enters micro-cracks, freezes, expands. Standard masonry begins failing after 20 to 30 cycles. The Rideau Canal has experienced 198 freeze-thaw cycles between 1832 and 2024. Modern limestone structures show significant spalling and crack propagation after 50 cycles without protective sealants. The canal's 6-foot walls show surface weathering but no structural deterioration. The construction method explains this. Workers excavated to bedrock, at 12 to 15 feet below planned water level. Foundation blocks were placed directly on granite bedrock or driven timber piles extending to refusal depth. The blocks themselves were dry stacked in some sections. No mortar. The wall strength came from gravitational compression and precise block fitting. Each block was inspected before placement. Cracks wider than 1/8 inch disqualified the stone. Surface irregularities beyond half-inch tolerance disqualified the stone. Rejected blocks were used for secondary structures or fill. The dry stacked sections move slightly during freeze-thaw cycles. The blocks shift, absorb expansion forces, return to position during thaw. The quarter-inch gaps between blocks allow enough movement to prevent cracking. The 6-foot thickness provides thermal mass that moderates temperature fluctuations in the wall core. The outer surface weathers. The interior remains stable. Lock operations began in 1832. The first commercial vessel was the steamboat Rideau, carrying passengers and cargo from Kingston to Ottawa. Early traffic was modest. The canal competed with the St. Lawrence River route, which offered faster transit but required portages around rapids. The canal provided a safer alternative during periods of political tension, but that advantage disappeared as relations stabilized. Traffic peaked in the 1860s during the timber trade boom. Massive squared timber rafts, each containing hundreds of logs, passed through the locks. The limestone walls absorbed impact from these heavy loads. A modern engineering analysis shows the walls were overbuilt by a factor of 4 to 5 for the actual hydraulic and impact loads they carried. They were designed for war. They instead served commerce. The timber trade declined after 1900 as railways provided faster transport. Canal traffic shifted to recreational vessels. Small pleasure boats replaced commercial timber rafts. The 6-foot walls designed for 20-ton cargo vessels now support 2-ton sailboats and motor yachts. The infrastructure was oversized for its new purpose. Parks Canada assumed management in 1972. Engineers conducted comprehensive structural surveys every decade. The 1975 survey documented wall condition after 143 years of service. Findings: maximum settlement 2 to 4 inches, concentrated in foundation areas with clay substrate rather than bedrock. Block displacement minimal. Mortar degradation in exposed joints required repointing. Protected sections showed negligible deterioration. The limestone blocks themselves required no replacement. The 1995 survey, after 163 years, showed similar results. Wall settlement had stabilized, and no additional displacement beyond the initial 2 to 4 inches recorded in 1975. Surface biological growth, lichen and moss on north-facing walls. This colonization does not affect structural integrity. The 6-foot thickness absorbs surface weathering without compromising load-bearing capacity. UNESCO designated the Rideau Canal a World Heritage Site in 2007, citing the original stonework and operational continuity. The designation specifically noted the engineering integrity, structures built for military purposes that never saw military use, yet survived longer than comparable military installations. The walls were overbuilt for a threat that never materialized, but that overbuilding ensured their survival. Modern concrete lock structures show different performance characteristics. The Welland Canal, built with reinforced concrete between 1913 and 1932, requires continuous maintenance. Concrete spalling, steel reinforcement corrosion, alkali aggregate reaction. These are standard deterioration modes for early 20th century concrete. The Rideau Canal's limestone construction avoids these failure mechanisms. And stone doesn't corrode. Freeze-thaw is the primary stress, and the 6-foot thickness provides redundancy that concrete cannot match at reasonable cost. A structural engineer reviewing the Rideau Canal specifications in 2015 noted the safety factors. Hydraulic pressure calculations show 6-foot walls carrying loads requiring 18 inches maximum. Foundation depth of 15 feet where 6 feet would suffice. Block quality standards rejecting 40% of quarried material. These margins are difficult to justify in modern economic terms. The engineer's conclusion: the canal wasn't built to survive 200 years of commercial service. It was built to survive sustained military assault. The fact that it serves recreational traffic 192 years later is incidental to the original design intent. The walls still stand. Lock gates have been replaced 8 to 12 times, depending on location. Timber gates rot. Steel gates corrode. Hydraulic systems require maintenance. But the limestone blocks placed between 1826 and 1832 remain in their original positions. The mortar has been repointed in sections. The stone has not been replaced. Colonel John By died in 1836, 4 years after the canal opened. He believed he had failed. The cost overruns destroyed his reputation. He never saw the canal's long-term success. The British government saw only the budget scandal. The limestone walls he specified were criticized as excessive. 6 feet where modern analysis suggests 3 would suffice for water pressure alone. But By wasn't designing for water pressure. He was designing for artillery impact, for siege conditions, for sustained bombardment by an enemy that never came. The threat assessment was wrong. The engineering was not. The walls he built for war have outlasted the empire that commissioned them. The stone remains. Modern maintenance costs are modest. Parks Canada spends approximately $2 million annually on the entire 202-kilometer system. Most spending goes to mechanical systems, lock gates, hydraulic rams, control systems. The limestone walls require minimal intervention, but repointing every 20 to 30 years. Vegetation removal, drainage maintenance, the masonry itself is stable. If the Rideau Canal were designed today, the specifications would differ. Modern engineering standards would specify reinforced concrete, thinner walls, optimized load calculations, reduced safety margins. The construction would cost less. The lifespan might be shorter. The maintenance burden would certainly be higher, but it would meet contemporary requirements. Oh, the 6-foot walls were not built to contemporary requirements. They were built to survive what their designers feared most. That fear was misplaced. The invasion never came. But the caution that drove the overbuilding, the conservative engineering, the redundant margins, the material quality standards, ensured the structure's survival long past its intended purpose. The walls stand. After 192 years of freeze-thaw cycles, impact loads, hydraulic stress, yes, they remain structurally sound. They were built for a purpose that never came to pass. They endure for a purpose their builders never imagined. The stone remains,